We now write a seventh degree polynomial whose zeros and their multiplicity are given here. That is, this polynomial should have a zero of 2 and its multiplicity is 2. And then it should also have a zero of -1 with multiplicity 3. And then there is one complex root that is 7 minus I. First, let's look at this complex root. All complex roots should always come in the conjugate form as well. So if we have this complex number 7 minus I as one of the root and its conjugate form, that is 7 plus I, will also be the root of this polynomial. So considering these roots as well as the multiplicities, we are going to write down the polynomial f of x in factor form. So let's consider the root 1 and this equals 2 and its multiplicity is 2, and then root 2 and this equals -1, its multiplicity is 3, and then we have two more roots, that is root 3 is 7 minus I, and then root 4 is 7 plus I. So using these roots as well as their multiplicities, we'll write the f of x. So I'm going to write f of x, and this equals, we should write down in factor form. So we put x minus of root 1 with its multiplicity. So here it is 2, and then x minus of root 2 and its multiplicity, that is here it is 3, and then we have this two more roots, that is x minus root 3 times of x minus of root 4. Now let's replace the root 1, root 2, root 3 and root 4 with the corresponding roots. So therefore we have f of x, and this equals x minus root 1 is 2, so it becomes x minus 2 square, and then root 2 is -1, so it becomes x minus of minus 1, which is positive 1. So it is x plus 1 raised to the power of 3, and then we have x minus of root 3 is 7 minus I. Since it has two terms, I'm going to write down in terms of brackets. So this is x minus of 7 minus I times of root 4 is 7 plus I. So I write down in brackets, that is minus of 7 plus I in brackets. Now we have to simplify and write it in factored form. So we have f of x. I write down the first two factors as it is with their multiplicity. So it is x minus 2 square times of x plus 1 cube. And let me simplify this. We have x minus 7 plus I, and we will also simplify this. Here we have x minus 7 minus I. Now let's look at only these two factors. We have x minus 7 plus I and x minus 7 minus I. So we will consider this x minus 7 as one term and then this I as another term. So basically, it is in the form of a difference of squares. That is, if you consider x minus 7 as a and this I as b, here we have a plus b, and the next term is considering x minus 7 as a, we have a, and then if you consider I as b, it is minus of b. And so this is basically the expansion or the other form of the difference of squares. So it is exactly equal to a squared minus b squared. That is, the difference of squares is identical to a plus b times a minus b. So we can take the reverse of it, that is a plus b times a minus b equals the difference of squares a squared minus b squared. So using this, we can simplify or we can find the product of these two terms. So therefore, I write down f of x, and this equals x minus 2 quantity square times x plus 1 quantity cube, and then times of I'm going to use this identity a squared minus b squared. I know a is x minus 7, so it is x minus 7 quantity squared minus b is I, so I put I quantity squared and then close this bracket. Let's simplify this. So we have f of x equals x minus 2 quantity squared times x plus 1 quantity cube. And let's expand this using the binomial expansion. That is, if we have a minus b quantity squared, this equals a minus b multiplied with itself a minus b. Otherwise, we can also use this, that is, this is identical to a squared plus b squared minus 2ab. In fact, when we FOIL this out, a minus b with itself, you will get this expression. So let's use this. So first I put a squared, considering x as a, it is x squared, plus considering 7 as b, it is 7 squared, which is 49. And then we have minus 2 times of a is x, and that is a is x and b is 7. So it is 2 times of x times of 7, which is 14x. So I write this as negative 14x. And then I squared, this is, remember that the value of I squared is negative 1. So it becomes, we already have a negative. So negative of negative 1 is a positive 1. So this is how it gets simplified. Now we can simplify this further. That is 49 plus 1 is 50. So therefore we have f of x, and this equals x minus 2 quantity square times x plus 1 quantity cube times we have x squared. Then I write this negative 14x term, and then 49 plus 1 is 50. So this is the factored form of the seventh degree polynomial f of x. We can easily check this. This is the seventh degree because here we have quantity squared. So therefore, the highest degree of this term will be x squared, and here we have power of 3. So therefore, the highest degree of x will be x cube, and here we have x squared, which is the highest degree of x. So when you multiply all these terms, you will get x raised to the power of 2 plus, we have to add the powers, 2 plus 3 plus 2, and this equals x raised to the power of 7. So when we multiply all these factors, the highest degree of x will be 7. That confirms that this is a seventh degree polynomial. So this is the seventh degree polynomial in factored form.